Alkanes are a family of organic compounds known for their unique carbon-to-carbon triple bond. The word alkanes refers to hydrocarbons that feature this strong triple bond. These molecules belong to the broader category of organic chemistry, which studies compounds based on carbon atoms. Remember, whenever you see a carbon triple bonded to another carbon, it indicates an alkane structure. Their distinctive properties and reactions make alkynes an important topic for any student of chemistry. Alkynes are unsaturated hydrocarbons. This means they contain fewer hydrogen atoms compared to similar saturated compounds. Their defining feature is at least one triple bond between two carbon atoms. A general formula for alkynes is carbon subscript N, hydrogen subscript 2N-2, spoken as CnH2n-2. With this structure, alkynes can easily participate in chemical reactions, making them very important in organic chemistry. The carbon-to-carbon triple bond found in alkynes is made up of one sigma bond and two pi bonds. The sigma bond forms the basic connection between the carbon atoms, while the pi bonds add strength and reactivity. Alkynes also have a unique bonding arrangement called sp hybridization, which gives the molecule a straight, or linear shape with a bond angle of 180 degrees. This linear geometry is a key characteristic that differentiates alkynes from other hydrocarbons. Naming alkynes follows simple rules set by the International Union of Pure and Applied Chemistry, or IUPAC. To name an alkyne, take the name of the corresponding alkane and replace the suffix -ane with -un. For example, if the alkane is ethane, the corresponding alkyne name becomes ethyne. The ending -un indicates the presence of a carbon-to-carbon triple bond. Some well-known alkynes include compounds like ethyne, propyne, and 1-butyne. Ethyne, also called acetylene, has two carbon atoms and two hydrogen atoms. Its formula is written as C2H2. Propyne has 3 carbon atoms and 4 hydrogen atoms. 1-butyne is made of 4 carbon atoms and 6 hydrogen atoms. The structural formulas use a triple bond symbol, showing the direct connection between two carbon atoms. Alkynes have interesting physical properties. They are nonpolar molecules, meaning that their atoms share electrons evenly. Because of this, alkynes do not dissolve well in water, but do dissolve in organic solvents like ether or benzene. The boiling points of alkynes are slightly higher than those of alkenes with the same number of carbon atoms. Terminal alkynes, those with a triple bond at the end of the chain, are weakly acidic, which can influence their chemical reactions. Alkynes participate in several important chemical reactions. One is hydrogenation, where additional hydrogen atoms are added, turning alkynes first into alkenes and then into alkanes. Another is halogenation, which involves adding halogen atoms to form dihalylkenes. Hydration is also key, as adding water results in carbonyl compounds like aldehydes and ketones. These reactions show how versatile and reactive alkynes can be in organic synthesis. To summarize, alkynes have a triple bond consisting of 1 sigma and 2 pi bonds. They exhibit sp hybridization and thus have a linear structure. Their reactivity is high due to unsaturation, and they readily undergo addition reactions that produce alkenes or alkanes. Understanding alkynes and their properties is foundational for mastering organic chemistry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.